double the size of the other. Does this answer make sense?
Yeah.
Yeah.
If you were feeling scary clever, here's sort of the ultimate reward.
Scary clever.
Scary clever.
I don't think I'm scary clever.
2 minus 2i over 1 minus i. Doesn't that equal 2 times 1 minus i over 1 minus i? So doesn't that equal 2?
What?
That's annoying.
What did you just do?
Because
A little bit of algebra 1.
But that's really, you don't have to do that. You just have to know that 1 is, that 2 is
You factored?
double 1.
Yeah, factor.
You can factor?
Call me crazy, I know. I can
I
factor.
will.
And then if it says leave it in polar form, well, 2, I hope you're starting to get the idea that 2 can always be written as 2 cis 0 just because it's 2 on the number line.
Say that he's crazy.
You guys like that trick?
Say it.
I'm not
Anyway,
gonna say it.
so there's a couple different ways you can do this, of varying lengths of time, depending on where you're at with it. Any questions on this before I erase it? Going once?
Are you a wizard?
But I have a question.
Abracadabra. Anyway, yes.
Okay.
It's a vodka
It
dog.
makes sense that 2.
That's my favorite.
See how it says 2 cis 0?
Yeah.
Isn't the cosine and sine of 0 both 0 and then you
Nope.
multiply
Cosine of
everything?
0 is 1.
Cosine of 0
Is 1.
no?
Yes.
Oh.
It's on the x-axis.
Yeah, it's the x-axis.
Okay, but then you multiply by the sine of 0, which is 1.
Sine of 0 is 0.
I mean, sine of 0 is 0.
Right.
So then you multiply.
So what this means, yeah, so good. So 2 times the cosine, this is 2 times 1 plus 2 times 0 i, which is 2.
Why isn't it 2? Why don't it makes it look like it's multiplication with that stupid cis?
It's cosine plus I sine, yeah.
Why did it do that?
I didn't make it up,
Why can't it
sweetie.
be C plus S? And the I is like, that would make my life so much easier.
Alright, I apologize that it's not. But since I can't fix the notation, and I do have to prepare you for college classes where you're stuck with the notation, I know, C plus S would actually make a lot more sense. It would explain what was going on. It'd be a great visual cue.
It should
This
be
spells
CSI,
Cisco.
actually.
Alright, new
First.
stuff.
Should be.
Last new thing.
Cis cosine.
For the geometrically minded of you, this will go very quickly. For the less geometrical minded of you, this will
Suck.
be a little more annoying. Yes, basically. But today on December 2nd or 3rd?
Second.
Second. Thank you. If you guys hadn't yet noticed how incredibly dorky I am, this is my favorite theorem that I'm about to teach you, actually. I have a favorite theorem.
This is my favorite.
It really is.
This of all of them.
I'm probably going to misspell it, but it is called de Moivre's theorem.
Rene Descartes.
Definitely mispronouncing it. De
We need to
Moivre's
know the
theorem.
name.
Did what?
God, your guess, your guess is better than mine. De Moivre's theorem can be summed up a couple different ways. Here's one of them. It's based on an idea, and the idea is this: what I'm about to write is not the theorem; it's the idea behind it. If you look for a root of a number, nth root of a number, maybe it's a square root, maybe it's a 8th root, maybe it's a 27th root of a number. If you look for the nth root of any number, there are n roots. Now this is not what you've been taught in general, except for in one case. If you look for a square root, like the square root of 4, how many answers should you anticipate?
2.
Now this is consistent with this statement. Plus or minus 2 are both answers, and there's an understood 2 here in this root, up here in this radical. So this works with this statement, but you've been taught something else. You've been taught, for example, that the cube root of -8, you've been taught to say what single number, when multiplied by itself 3
2.
times, gets you -8.
2.
Negative 2. And you should have also been taught that negative cube roots aren't a problem, because negative times a negative is a positive, times another negative gets you a negative again. So the cube root of -8, you've been taught, is just
Negative
2.
all odd.
All odd roots, you've been taught you have one answer, and it can be positive or negative. All even roots, you've been taught you have 2 answers, a positive and a negative. We're going to blow that out of the water here for a second. And here's what de Moivre's theorem basically says.
Should have zoomed in when he said we're going to blow.
On the imaginary plane, I'm using imaginary, I don't care anymore. On the complex plane, which I'm calling imaginary here, because I feel like it, the cube root of -8 would be a little bit differently. First off, the nth root of z being a complex number, you're going to find the nth root of the radius, and you're going to divide the angle by that root. Now this makes sense. This is consistent with what we've been doing, because we've been applying the operation to the radius, and we've been going sort of one operation behind on the angle. For exponents, you do the exponent on the radius and you multiply by the angle. For multiplication, you do the multiplication on the radiuses and you add the angles. Okay, so this part makes sense. But this gets you one answer. This gets you one answer, and there are always more. Okay, this gets you one answer. The rest are evenly spaced
because it can be anywhere on the circle.
on a circle, hence the word radius. Parker, as usual, gets the concept first. Let's see how he does with the application. Are evenly spaced on a circle, and the circle has a radius of this root. Give an example that we just did here. I'll do the -8 one. Let's see what we get. Let's see if it's consistent with what we know about real numbers. Okay,
What
so
do you mean by the rest?
the rest of the answers. If you look for an nth root of a number, there are n roots. So if you look for the cube root of -8 on the complex plane, you should expect 3 answers. If you look for the 5th root of something, you should expect 5 answers. And this formula will get you one of them, and the rest are evenly spaced in a circle on the complex plane.
So if my answer for that is 2, are the
You should-
rest going to be like 2, 4, 6, 8?
There's-
Like,
well, there's-
that doesn't make sense.
Hold this up. Let me give you a visual before I try to explain anything else. See if this helps answer your question. Okay, so let's say I ask you for all of the cube roots of -8. -8 is here, right?
Yep.
And I'm asking for the cube. I say I want all the cube roots of -8. I don't just say I want the cube root. That's your hint as to whether someone's talking about the imaginary plane or just real numbers. -8 in polar imag complex form would be, you can give me this one. Polar complex form.
8 cis.
Very good.
180.
8 cis 180. Very good. Because it's 8 units away from the origin, and it's right along the negative axis, so that's a 180-degree standard angle. So the cube root of -8 is 8 cis 180. Okay? Now, according to this little formula here, I'm actually looking for the cube root of 8 cis 180. So I find the cube root of 8, and the angle becomes 180 divided by 3. So my first answer is 2 cis 60. 2 cis 60, very good. So that's going to be roughly here. Now, if the other answers are evenly spaced on a circle, and there are 3 of them, how many degrees apart are they on the circle? How many degrees are there in a circle?
360.
360. So I take 360 degrees
So-
divided by n, and what does that get me?
Am I in the way?
No.
Oh, isn't that how you find out how many angles are on a polygon?
Yes, very similar, very similar. Now, n in this case is 3, because I'm looking for a cube root. So what's 360 divided by 3?
120.
120. Okay, so take a moment, pause to reflect. All the answers are evenly spaced around a circle. There's 3 of them, so they have to be 120 degrees apart. The first one, according to this formula, is at 2 cis 60. Where's the next one? What's 120 degrees away from
180.
60? 180. So I go 120 degrees this way, and that takes me right here to 2 cis 180. Is that an answer we anticipated?
Yes.
Yeah, the cube root of